Hey, what is up guys? Welcome to another video. In this video I'm going through an Edexcel higher sample paper written by Churchill Maths. In my opinion, this paper by Churchill Maths is really well written because it's similar to the official Edexcel papers. If you haven't seen this paper before, you can go to their website. I'll put a link in the description. And on the first page you come to, you can see down the bottom of the page there's some links to the papers, and you can download this one along with the mark scheme for free. There are also papers for the OCR and the AQA exam boards as well. Even if you're studying for Edexcel, there's no harm in having a go at the AQA papers or the OCR papers, as that's still good general revision for exams. People have been asking me to do more past papers and more mock exams, so I'll be trying to find more papers that haven't been covered by other YouTubers already. Other than that, let's get straight into the questions. Question 1 says, Jeremy, Kira and Liz are maths teachers. Jeremy can mark 12 homeworks in an hour, Kira can mark 30 homeworks in 2 hours, and Liz can mark 1 homework every 6 minutes. Part A says, show that Kira is the quickest of the 3 teachers at marking homework. So in order to compare their rates of marking homework, we need to have them we need to find either how long it takes each of them to mark 1 homework, or how many homeworks they can mark in a set period of time, say how many homeworks per hour. I'm going to find how long it takes them to mark 1 homework. So if I want to work out how long it takes Jeremy to mark 1 homework, if he marks 12 homeworks in an hour, I can divide this by 12. So divide 12 homeworks by 12, then I get 1 homework. And 1 hour divided by 12, or that's the same as 60 divided by 12. 12 goes into 65 times, so he marks 1 homework every 5 minutes. If Kira marks 30 homeworks in 2 hours, well, how long does it take her to mark 1 homework? I need to divide that by 30, so 30 divided by 30 is 1 homework. And 2 hours divided by 30, well, how many times does 30 go into 2 hours? Well, there's 4 half hours in 2 hours, so that's going to be 4 minutes. And Liz has already done for us. Liz marks 1 homework every 6 minutes. So now I can compare these ratios because I've found the time it takes to mark 1 homework for each teacher, and I can see that Kira is the fastest. She marks 1 homework in 4 minutes. The second part of this question says, one night Jeremy and Kira work together to mark 36 homeworks. They both start at 4:30 p.m. and work until all the homeworks are marked. What time do Jeremy and Kira finish marking? To answer this question, I want to know their combined rate of marking. So I know that Jeremy marks 12 homeworks in 1 hour. So his rate is 12 homeworks per hour. And Kira marks 30 homeworks in 2 hours, so she's marking 15 homeworks in 1 hour. So Kira's rate is 15 homeworks per hour. So together, they're marking 27 homeworks per hour. So I know their combined rate is 27 homeworks in 1 hour. And I want to know how long it takes them to mark 36 homeworks. So I can solve this using equivalent fractions. Now, I know how many homeworks they need to mark. I don't know how long it's going to take them, so I can put an unknown in here, say x. So 27 per hour will equal 36 per whatever time that's going to take. And then here I can just solve for this unknown. So the way I can do this is just rearrange this slightly. So x is going to be the number of homeworks divided by the rate that they mark homeworks. So 27 goes into 36 once, with 9 left over. So 36 over 27 is going to be 1 and 9 27ths. 9 over 27, well 9 is a third of 27, so this is just 1 and a third. And in terms of hours and minutes, a third of an hour is 20 minutes. So this is going to be 1 hour and 20 minutes. So it's taken them 1 hour and 20 minutes to mark 36 homeworks. If they started at 4:30 p.m., 1 hour after 4:30 p.m. is 5:30 p.m. and another 20 minutes, that's going to be 5 5:50 p.m. that they finish. There are other ways to do this, so you could recognize that if it takes 5 minutes for Jeremy to mark one homework and 4 minutes for Kira to mark one homework, then they can mark 9 homeworks in 20 minutes. And then you can work out that it takes them 1 hour to mark 27 homeworks. So, and 9 plus 27 is 36. So in that way you could have worked out that it takes 1 hour and 20 minutes. So there's a number of different ways you can work this out. This, in my opinion, is just the most logical, so that's the way that I prefer, but there's nothing wrong with this method either. As long as you're showing the method you're using and showing you're working out, you'll be fine. Question 2 says, Toby makes bracelets by putting 8 beads, 4 spaces and a heart charm on a silver chain. He buys the separate items in bulk at the following prices. 20 silver chains costs £180, 500 beads cost £750, 100 spaces cost £90 and 30 heart charms cost £120. We need to work out the cost of the materials for one bracelet. What I'm going to do is to work out the cost of one of these items each. There are other ways to do it, so you can just jump straight to working out the cost of one silver chain, the cost of 8 beads, the cost of 4 spaces, etc. But I'm going to do it by working out one and then multiplying that by the number of items I need to get the price. So for silver chains, for one I need to divide it by 20. So for one silver chain I'll need to divide 180 by 20, and 180 divided by 20, that's 9. So one silver chain costs £9. For the beads, the cost of one I need to divide by 500. So 750 divided by 500, well 500 goes into 750 once, and then 250 is half of 500, so this is going to be £1 and 50 pence. For the spaces, the cost of one is going to be dividing that by 100. So £90 divided by 100, that's going to be 90p. And then for the heart charms, one is going to be dividing that by 30, so £120 divided by 30, that's going to be £4. So now I have the cost of one of each of these, and I can work out the costs of how many I need for one bracelet and then add those together. So I need one silver chain, so that's going to be £9 for the silver chain. I need 8 beads, 8 times £1.50, that's going to be £12. I need 4 spaces, 4 times 9 is 36, so that's going to be £3 and 60 pence. And then I need 1 heart charm, so that's just going to be £4. And if I add all of those together, well, there's going to be 60p on the end. Then 9 plus 2 plus 3 plus 4, that's 18. Carry the 1. 1 plus 1 is 2. So the total price there for one bracelet is £28 and 60 pence. The second part of this problem says, at a market one day, Toby sells 15 bracelets for $39.90 each. How much profit does he make at the market? So what we need to do is to work out how much it costs to make 15 bracelets and how much he made in total, then subtract the cost from how much money he made on the day. One way to do this is to multiply 15 by 2860 and multiply 15 by 39.90 and then subtract those totals. Or we could work out the difference and then multiply that difference by 15. So that's the way I'm going to do it. So he's selling them for $39.90 and he's making them for $28.60. So the difference in cost there, if we subtract these, is going to be 0 take 0 is 0, 9 take 6 is 3, 9 take 8 is 1, and 3 take 2 is 1. So the difference in cost is £11.30. And then we can multiply that by 15. Multiply that by 15 to get how much profit he made. When you're multiplying numbers with decimals, remember to remove the decimal before you multiply, and then you need to make sure to put it back in at the end. So if we multiply 113 by 15, we need to do the ones first. So 3 times 5 is 15, carry the 1. 1 times 5 is 5, plus 1, that's 6. 1 times 5 is 5. Then we need to do the tens, and that's just going to be 113. Then we add these up. 5 plus 0 is 0, 9, 6, 1. And then we need to remember to put the decimal place back in. So the total profit there is going to be 169.5, or £169.50. Question 3 gives us a grid, and it says the shapes A, B, C, and D are shown on a coordinate grid. Which of the shapes B, C, and D are congruent to shape A? Now remember what congruent means. It means the same shape and size. I've done a video on congruence if you want to watch that. So clearly C is not congruent to A. It's not the same size. And it looks like B and D are congruent. And just to make sure, let's have a look at the sides. So this side here has a height of 2 and a length of 1, the same as this side. This side here is the same. This is a diagonal of 1 square, that's the same, and this side's the same as well, same for B. So we can see that B and D are congruent. Shape A is translated by the vector PQ to give shape B. Write down the values of P and Q. So remember, the top number in a vector is the horizontal movement, or the movement along the x-axis. The Q is the vertical movement, or the movement along the y-axis. And so the way I like to do this is to pick a point on the shape and see where that ends up on the translated shape. So if I go across 4 squares and down 5 squares, I end up at the same point on B. So I've gone across 4 in the positive direction, and I've gone down in the negative direction. So this is going to be 4 minus 5. Part C says shape A is enlarged to give shape C. Write down the scale factor of the enlargement. So we've got shape A here, and if we look at shape C and we look at one side of shape C and compare it to the same side on shape A, we can see it's enlarged by a scale factor of 2. So this is 1 unit and this is 2 units, so I've multiplied that side by 2, so the scale factor must be 2. Part D says shape A is reflected in the line L to give shape D. Write down an equation for the line L. So we've reflected A in a line to give shape D. Where does that line exist? Well, if we look at this point and this point, where is the midpoint between those two? So there's 4 squares between them. So we need to go 1, 2, and there's the line here. That's the mirror line to reflect A to D. And we need to work out the equation of this line. Well, every vertical line has an equation of x equals something. And the equation is where that line crosses the x-axis. So this line crosses the x-axis at 1, so this is going to be x equals 1 for that line. Question 4 says, make Q the subject of the formula P equals 4Q minus 7. We need to rearrange this formula in order to make Q the subject, in other words, Q by itself on the left-hand side. So the first thing I'm going to do is switch it around. So 4Q minus 7 equals P, and then add that 7 to this side. So then I have, the next line will be 4Q equals P plus 7. And then to get rid of that 4 on this side, I need to divide the right-hand side by 4. So Q is going to equal P plus 7 divided by 4. Let me just write that a bit more neatly. So Q equals P plus 7 divided by 4. Question 5 gives us a diagram. The diagram shows a circle with center O. The straight line XY is a tangent to the circle at the point P. Work out the value of A. Now there's one theorem about angles in a semicircle if they are subtended by the diameter. If there's a diameter and there's a triangle formed from the ends of that diameter, the angle in that triangle will always be a 90-degree angle. So we can say angles subtended by the diameter equal 90 degrees. Now if we look at this carefully, these are angles on a straight line, so A, 90 and 38 degrees, they're all angles on a straight line, so they must add up to 180 degrees. So we can say therefore A plus 90 plus 38 must equal 180 degrees. So therefore A equals 180 minus 90 minus 38. So 180 minus 90, that's 90. Minus 38, 90 take 38, that's 52. So A equals 52 degrees. Question 6 says, a company selling clothes online decides to check the productivity of its workers. The table summarizes the number of orders N packaged by 120 employees on one afternoon. So here in the table we can see the number of orders on the left, going from 40 all the way up to 75, and the frequency of those numbers of orders. So 4 people were packaging between 40 and 45 packages, and this was in one afternoon. There were 17 people packaging between 45 and 50 packages in one afternoon. There were 33 people packaging between 50 and 55, etc. So you can see here the most common frequency was 33 between 50 and 55. Part A says complete this cumulative frequency table. So cumulative frequency is just adding up the frequencies as you go up the table. So 4 plus 17 will be the next cumulative frequency in here. So that's going to be 21. And then we add that 33 to this total. So 33 plus 21, that's 54. And then 25 plus 54, that's 79. Then 20 plus 79, that's 99. Then 14 plus 99, that's 113. And then 7 plus 113, that's 120. Then part 2 of this question says, draw a cumulative frequency graph for this data on the grid on the next page. Okay, so here we've got a grid with no axes labeled, so we need to figure out the scales and then label the axes. So on a cumulative frequency graph, the y-axis is always labeled the cumulative frequency. And the x-axis is whatever the variable is. So here we're number of orders. Number of orders. N. And we need to figure out the scale. So the number of orders went from 40 to 75. So we could go up in fives. So if I start at 40 here, and then 45, 50, 55, 60, 65, 70, 75, and this symbol means kind of you've shrunk that a little bit. The cumulative frequency goes up to 120, so it looks like I could go up in tens here. So 10, 20, 30, and 120, so that just fits. Now on a cumulative frequency graph, the frequencies are plotted to the maximum value in that range. So the point for the first interval will be 445. That's saying there were 4 people that packaged up to 45 orders. And then the next point will be 2150, saying that there were 21 people who packaged up to 50 orders. So these plots are pointed at the maximum value of these intervals. So the first point here is 445. So on my scale here, each of these squares is worth 2, so 4 is going to be here, and then at 45, so that's my first point. My next point is 2150. 21 will be halfway between these two squares, so my next point is there. The next point is at 5455, so 54 is about here, and 55 on the x-axis. The next point is 7960, so 79 on the cumulative frequency, and then 60 on the number of orders. The next point is at 9965, so 99 is here, and then 65 on the x-axis. And the second last point is 113 and 70, so 113 is here, and 70, so the point will be there. And then the last one is 120, 75. So I've plotted all my points. Now I need to draw in the graph. So what you need to do is to sketch this graph in as neatly as possible. I'd suggest doing this with a pencil just in case you slip and make a mistake. You should always be drawing graphs with pencils, really. So that's pretty rough. It's a bit difficult to do it on a computer. So we have our cumulative frequency graph. Part B says employees who packed 53 or fewer orders will have their productivity checked again the next week. How many employees will be affected? So we need to have a look at the number of orders is 53 or fewer. If we find 53 on the x-axis, so 53 is here, and we go up to the graph, and then across to the cumulative frequency. So you can see here why it's kind of important to get your curve fairly accurate, because if you're asked to do an estimate from the curve, you need to be finding the right values. So we've gone up from 53 on the number of orders and across to the cumulative frequency, and we've got about 42. So that's saying that there were 42 people that did less than 53 orders, 53 or fewer orders. So that means there are 42 employees affected. So if you got about 40 to 44, I think you should be okay. They generally have a range of answers for these types of questions with cumulative frequency, and if you get inside that range, then you get the mark. Question 7 gives us a diagram of a triangle, and it says the angles in triangle ABC are given in degrees. Prove that AB equals AC. So AB is this side and AC is this side, and we need to prove they're the same. One way I can see we can prove they're the same is either if this is an equilateral triangle or if it's an isosceles triangle, because all of the sides of an equilateral triangle are equal and two sides of an isosceles triangle are equal. One way we can prove this is either an equilateral or an isosceles triangle is by showing that all of the angles are the same or two of the angles are the same. Now, we're not given the angles, but we are given equations for the angles, and we've only got one unknown in here. So we'll be able to create an equation using these angles, and we know that the angles in a triangle add up to 180 degrees. So all of these angles must add to 180 degrees. So let's go ahead and write that down. So we've got 4x plus 3x plus 20 plus this angle here, 5x minus 8. And all of those added together must equal 180. So you can see we've created an equation which we can simplify and then solve. So the first step is to combine like terms, so we can add 4x plus 3x plus 5x. That's going to be 12x. And then 20 minus 8, that's going to be plus 12, equals 180. And then we can subtract that 12 from the left-hand side. So 12x equals 180 minus 12, that's 168. And then x equals 168 divided by 12. Here you can think of your 12 times tables. So 12 times 12 is 144, 12 times 13 is 156, and 12 times 14, that must be 168. So 168 divided by 12, that's going to be 14. So now we know that x equals 14, we can figure out what these angles are. Let's start with these two base angles. So we can substitute x back into these expressions. So 3 times 14 plus 20. 3 times 14, that's 42, plus 20, that's 62. So that's angle ABC. Then angle ACB is going to be 5 times 14 minus 8. 5 times 14, that's 70, minus 8. That's going to be 62 as well. So we can see that these two angles are equal, and base angles of an isosceles triangle are always equal. We know this must be an isosceles triangle, which means that these two sides are equal, and so therefore we've proved that AB equals AC. So we can say something like angle ABC equals angle ACB. So therefore triangle ABC is isosceles. So therefore AB equals AC. Question 8 says, the number of emails Leanne sent this week is 20% more than last week. This week Leanne sent 240 emails. Work out how many emails Leanne sent last week. So let me just state this information a little bit differently. So we're taking the number of emails last week, we've increased it by 20%, and now we've got 240 emails. So that means that the number of emails last week, which we don't know, multiplied by 1.2, because if you multiply something by 1.2, that increases it by 20%. That must equal the number of emails this week, 240. So we're looking for this number which we multiply by 1.2 to get 240. Let's just put a variable in here to make it a little bit more clear. So we can work out what this x is, this unknown is, by dividing 240 by 1.2. So x, the number of emails last week, will be 240 divided by 1.2. As this is a non-calculator paper, what I'm going to do is to multiply both of these by 10, because this is still the same fraction if I multiply the numerator and denominator by 10. So this is going to be 2,400 divided by 12. 24 divided by 12, that's 2. So 2,400 divided by 12 must be 200. So the number of emails last week was 200. Another way to do this question is to say that, well, if we've increased the number of emails by 20%, we can say that the number of emails this week is 120%. So 120% equals 240. And then we could work out, say, 10% by dividing both by 12. So 120 divided by 12 is 10, and 240 divided by 12. 240 divided by 12, that's 20. So 10% equals 20. So then to work out 100%, we can multiply both of those by 10, and we get 200. So that's another way to approach this type of problem. Question 9 says, a model of bicycles is available in 5 frames. For each frame size, there are 7 possible colors. There are 3 sets of gears that can be fitted on the smallest 2 frame sizes and 6 sets that can be fitted on the 3 larger frame sizes. Part A says, Noah is buying the largest frame size. How many different ways can he choose the color and the gears for his bike? There's a lot of information in this question, and it's all kind of shoved together, and it's a bit difficult to kind of pull it all out. So maybe get a highlighter or underline the key piece of information to make it a little bit more clear. So we've got 5 frame sizes, 7 possible colors. There are 3 sets of gears for the smallest 2 frame sizes and 6 sets for the 3 larger frame sizes. So, and the question part A is saying, how many different ways can he choose the color and the gears for his bike if he's choosing the largest frame size? So there are 3 larger frame sizes. There are 6 sets of gears that fit on the larger frame sizes. So there are 6 different types of gears he can choose. And there are 7 possible colors for each frame size. So there are 6 gears and there are 7 different colors. So the number of combinations will be 6 multiplied by 7. So 6 times 7, that's 42. So there are 42 different ways to choose the color and the gears for his bike. Part B says here is part of a leaflet about this model of bike, and the leaflet says available in blank combinations of frame, size, color and gears. What number is missing from the leaflet? So we need to work out the total number of combinations of frame, size, color and gears. Okay, let's go back to the question. So there are 3 sets of gears for the 2 smaller frame sizes and then 7 possible colors for those. So we've got the 2 smaller frame sizes multiplied by the number of gears multiplied by the number of colors that he could have. So what we end up with there is 2 times 3 times 7, which is 6 times 7, which is 42 again. So we get 42 different combinations for the smallest frame sizes. And then for the larger frame sizes, we've found the number of combinations for the colors and the gears. So there are 42 different combinations for the colors and gears. And then there are also 3 different frames that you can choose. So we need to multiply that 42 by 3 to get the number of combinations for the larger frame size. So if there are 42 different combinations for each frame size, we need to multiply that by 3. 42 times 3, that's 120, 126. So for the smaller frame sizes, there are 42 different combinations. For the larger one, there's 126. So in total, we can add those together. 126 plus 42, that's going to be 168 total combinations of bikes for 2 marks. Question 10 says, a bag contains only red beads and blue beads. Faria picks out a bead at random, notes its color and puts the bead back. Faria does this 10 times and gets a red bead 7 times. Faria says there are more red beads than blue beads in the bag. Comment on Faria's statement. Well, she could be correct. There's a possibility that she could be correct, but she could also be wrong. It's likely there are more red beads in the bag, but we can't be certain because she's only done it 10 times. There's a small chance that there might be an equal number of red beads, or there might even be less red beads, but she just got lucky in picking out the red beads. So she'd need to do the experiment maybe 100 times or 200 times to be certain that there are more red beads in the bag. So we can say that she hasn't done the experiment enough times to say there are more red beads in the bag. So we can say the number of trials is too small to be certain. She may be wrong. The second part of this question says Rosa, Shamila and Tess each do the same experiment as Faria. Here are all the results. So we've got a table with the number of times the red bead is picked and the number of times the blue bead is picked. Faria is going to pick out another bead and put it back in the bag. Using the results in the table, work out the best estimate for the probability that she picks out a red bead. Key word there being best estimate. So what this is saying is that we need to take all of these experiments and combine them. The larger the number of trials, the better the estimate of the probability. So if we add all of these up, we'll have the best estimate for the probability. They've each done the trial 10 times. There's going to be 40 trials here. And let's add up the number of times the red bead was picked. So 7 plus 6 plus 8 plus 6, that's going to be 27. 3 plus 4 plus 2 plus 4, that's going to be 13. So they've done 40 trials, 27 of which were red beads. So the best estimate for the number of red beads picked is going to be the number of times they picked the red beads, 27, out of the total number of trials, which is 40. So the best estimate there for the probability that she picks out a red bead will be 27 out of 40. The last part of this question says, in another bag containing beads, 60% of the beads are green. Faria is going to pick out 2 beads at random from the bag. She says the probability of both beads being green is a third, as you work out 6 out of 10 times 5 out of 9. Is Faria correct? Explain her answer. So we're told that 60% of the beads are green, which means that the first pick would be 6 out of 10, which equals 60%. However, we're not told how many beads are in the bag, so we can't say the next probability would be 5 out of 9. What if there were 100 beads in the bag? Well, the first pick would be 60 out of 100, and then the next pick would be 59 out of 99. 59 out of 99 is not the same as 5 over 9. So because we're not told the number of beads in the bag, we can't know the probability of the second pick. So we can say that Faria is wrong. We are not told the number of beads in the bag. Therefore, we do not know the probability of the second pick. Something along those lines will be fine for 2 marks. Question 11 gives us a triangular prism and a cube, and it says the triangular prism and the cube shown above have the same volume. The cross-section of the triangular prism is a right-angled triangle. Find an expression for the length of one edge of the cube in terms of p. So let's break this down a little bit. We are told the edges of the triangular prism are 3p, 2p, and 9p, and this is a right-angled triangle. We know that the side lengths of cubes are all the same. So the volume of a cube is, if we say this length is x, then the volume of the cube is x cubed. Now why is that important? Because if we can find an expression for the volume of this cube, we can find an expression for the side length, because the side length is the cube's root of the volume. If the volume is the side length cubed, the side length must be the cubed root of the volume. And we're told the cube and the triangular prism have the same volume. So what we need to do is to find the volume of the triangular prism in order to find the side length of the cube. So let's go ahead and see if we can find the volume of this triangular prism. Now any triangular prism is half of a rectangular prism. So if you can imagine this was a box and it's being kind of cut in half. If we created a rectangular prism and we sliced it in half, we'd end up with this triangular prism. So the way we work out the volume of a triangular prism is the same way we work out the volume of a rectangular prism, and then just divide that by 2. So we take all of the side lengths. So the volume is going to be 3p times 2p times 9p. Multiply those all together, and that would give you the volume of the rectangular prism if there was one. And then we just divide them by 2 to get the volume of this triangular prism. Okay, now we need to simplify this expression. So 3p times 2p times 9p. The first thing I can do is to multiply the coefficients. So 3 times 2 is 6. 6 times 9, that's 54. And then p times p times p, that's p cubed, divided by 2. Maybe you saw a simpler way. Can't I just cancel these 2's on the top and bottom line before I simplify the top line? Because I'm multiplying all of these numbers on the top line together, I can just cancel the numerator and denominator. So once I cancel those 2's out, this makes it a little bit easier to simplify. So I can just do 3 times 9, which is 27, p cubed. So the volume of the triangular prism is 27p cubed. Therefore, the volume of the cube is 27p cubed. So therefore, the side length of the cube as I said before, must be the cubed root of the volume So the cubed root of 27p cubed. Now the cubed root of 27 is 3. 3 times 3 times 3 is 27. And the cubed root of p cubed must just be p. So now we have an expression for the length of one edge of the cube in terms of p, which is 3p. Question 12 gives us a graph, and it says the diagram shows the velocity time graph for a cyclist riding along a straight road. Part A says, for how long during this ride did the cyclist travel at a constant velocity? So on the y-axis we have the velocity in meters per second. Along the x-axis we have the time in seconds. So when the velocity is constant, there must be a horizontal line. So this value here is 12 for the velocity. So along this straight line, the velocity is staying constant. Each point on this line is the same velocity. So the velocity stayed constant from these two times here. So if we look at this scale carefully, it's going up in 2s, 2, 4, 6, 8, 10. So this must be 12, and this is 20. So the velocity stayed constant from 12 seconds to 20 seconds. So that must be 8 seconds. Part B says, work out the acceleration of the cyclist 10 seconds after the start of the ride. Now, to work out the acceleration from a velocity time graph, you need to work out the slope of the graph. So the change in velocity over time. So if you imagine us starting at 0, and as we're riding along, we're increasing our speed. And the rate at which we're increasing the speed is the acceleration. And the rate at which we're increasing is the slope of the line. And this question is saying, work out the acceleration of the cyclist 10 seconds after the start of the ride. So we need to work out the acceleration at 10 seconds. In other words, the slope of that line when the time is 10 seconds. So we can see here that the acceleration stays constant between 6 seconds and 12 seconds. So if we work out the acceleration between these 2 points, we can work out the acceleration at 10 seconds. And the way we can do that is to work out the gradient of this line between 6 and 12 seconds. And the way we work out the gradient is to work out the rise over the run. So the rise here is from 8 seconds to 8 meters per second to 12 meters per second on the velocity axis. So the rise is 4, and the run is from 6 seconds to 12 seconds, which is 6. So the gradient here is going to be the rise over the run, which is 4 over 6. So the gradient of the line at 10 seconds is 4 over 6, which is 2 over 3, which is our acceleration. So the acceleration at 10 seconds is 2 over 3 meters per second squared. Part C says, work out the total distance traveled by the cyclist. To work out distance covered on a velocity time graph, you need to work out the area under the graph. So to find the area, we can break this shape up into 4 smaller areas, 4 smaller shapes which we can find the area of. Here we've got a triangle, and we know the base is 6 and the height is 8. And here we've got a trapezium. The length of this side is 12 and the base is 6 to 12, that's 6. Here we've got a rectangle and the height is 12 and the length is 8. And then here the last one is a triangle, the height is 12 again, and the base is 20 to 36, so the base is 16 there. So we can go ahead and work out the areas of these. So this one's going to be 6 times 8 divided by 2, that's 24. The next one is a trapezium. The way we work out the area of a trapezium is we add the top and bottom sides, multiply by the height, and divide by 2. So in this case, the top side is 8, the bottom side is 12, and the height is 6. 8 plus 12 is 20, times 6, that's 120, and divided by 2 must be 60. So the area in there is 60. This rectangle is just 12 times 8. 12 times 8 is 96, and the area of the last triangle will be 12 times 16 divided by 2, which would be the same as 12 times 8. 12 times 8 is again 96. So we have all of the areas here. 24 plus 60 plus 96 plus 96. So the distance will be 24 plus 60 plus 96 plus 96. If you add all of those up, you will get 276. So the total distance there is 276 meters. Question 13 says solve the equation 5y minus bracket 2 times 10 to the power 6 bracket equals 4 times 10 to the power 7. Give your answer in standard form. Now, if you haven't seen a question like this before, it can look tricky, but it's not really, because it's the same as solving an equation, but just with numbers in standard form. So what's the first thing? If we had, say, 5y minus 10 equals 4, what's the first thing you'd do to solve this equation? You would add that 10 to the right hand side. So here we're going to take this number in standard form, and add it to the right hand side. So we'll get 5y equals 4 times 10 to the power 7 plus 2 times 10 to the power 6. Now, in order to add numbers in standard form, we need to have the power of 10 to be the same. So we can either change this power of 10 to be 6 or this one to be 7. So I'm going to change the second one here. So what I get is 4 times 10 to the power 7 plus 0.2 times 10 to the power 7. So you can see here, if I've changed the power of 10 to 7, I need to divide this number by 10. 2 times 10 to the 6 is the same as 0.2 times 10 to the power 7. And then, because they've got the same powers of 10, I can add the number out the front here. So 4 plus 0.2, that's 4.2 times 10 to the power 7. So 5y equals 4.2 times 10 to the power 7. What's the next step? Well, there's a little trick here. I can multiply both sides by 2. So then I get 10y equals 8.4 times 10 to the power 7. The reason I do that is because then I can divide this side by 10. And if I divide this side by 10, all I'm going to have to do is to cancel out a number to the power of 10 here. So y is going to equal 8.4 times 10 to the 7 divided by 10, and that allows me to cancel one of the powers of 10 on the top line, and that becomes 6. So y equals 8.4 times 10 to the 6, which is your final answer. So if you got to this line here and you didn't see this little trick of multiplying by 2 to get 10y, you could still just do 4.2 divided by 5. So 4.2 divided by 5. So that's going to be 5 into 4 doesn't go, so that's 0. And then carry the 4. 5 into 42 goes 8 times. And then carry the 2. 5 into 20 goes 4 times. What you end up there is y equals 0.84 times 10 to the 7. And then if you change that into standard form, you get 8.4 times 10 to the 6. You'll still be fine doing it that way. That's just a little shortcut, multiplying everything by 2. Question 14 says, Henrik and Rob both work part-time in a shop. In a normal week, the ratio of what Henrik earns to what Rob earns is 3 to 2. In the week before Christmas, they each receive a £20 bonus. The bonus means that the ratio of what Henrik earns to what Rob earns becomes 4 to 3. How much does Henrik earn in the week before Christmas? This is probably my favorite question on this paper. You might not have seen a question like this before, so it's good practice to test your problem solving skills. There's a couple ways to approach this question. I'm going to show you my method. There's a different method on the mark scheme, so if you download the mark scheme, you can check out how to do it that way as well, and you can pick which one you prefer. But I'll show you the method that I prefer. So we know that the ratio of their wages, Henrik to Rob, equals 3 to 2 before the bonus. And we need to work out what Henrik earns in the week before Christmas. So if we add their wages together, there must be some total wage. We don't know what it is yet, so I'm going to call that X. Now if we look at this ratio 3 to 2, there's 5 parts in that ratio. 3 plus 2 is 5, so that ratio is broken up into 5 parts. So that ratio is effectively breaking this total wage up into 5 equal parts. and Henrik earns 3 of those 5 parts. So Henrik is earning 3/5 of the total wage. In the second ratio, after the £20 bonus, he's earning 4/7 of the total wage. You can see in the second ratio there's 4 to 3, so that's breaking the total wage up into 7 equal parts, and Henrik is earning 4/7 of that total wage. So what this is telling us is that Henrik's wage before the bonus is 3/5 of the total wage. Henrik's wage after the bonus is 4/7 of the total wage. Now, what is the total wage after the bonus? Well, it's the total wage that we started with plus £20 for both Henrik and Rob. So in total, we've increased this total wage by 40. So we take this total wage and we add 40. So after the bonus, Henrik is earning 4/7 of the total wage, which is the original wage plus £40. Now, how can I make these two things equal? Well, before the bonus, Henrik was earning 3/5 of the total wage. After the bonus, he's getting 4/7 of the total wage plus 40, and we're told he gets a £20 bonus. So his share before the bonus plus £20 equals his share after the bonus. So 3/5 of the original wage plus £20 must equal 4/7 of the wage after the bonus. I hope that's clear how I've created that equation, because now once I've created that equation, all I need to do now is to go ahead and solve this for x, which is basic simplification. So let's go ahead and start solving this now. So the first thing I want to do is get rid of these fractions. They look messy, they're annoying me, so I want to get rid of those fractions. The first step I'll do to get rid of the fractions is to multiply everything by 5. If I multiply everything by 5, I can cancel this 5 out, and I'll have gotten rid of this first fraction. So multiplying everything by 5, I'll have 3x plus 100 equals 20 over 7x plus 40. Then I want to get rid of this fraction, so I want to multiply everything by 7. If I multiply everything by 7, I can cancel that 7 out. So my next step here will be 21x, 3 times 7 is 21, plus 700 equals 20x plus 40. So I've got rid of the fractions, I'm happy. Then I need to expand out these brackets, so 21x plus 700 equals 20x plus 800. 20 times 40 is 800. And then I want to get all of the x's on the left hand side and all of the numbers on the right hand side. So I can subtract this 20x from the left, so I'll have 21x minus 20x, and on the right I'll have 800 minus 700. So then I've got x equals 100. Now, going back to the question, I had made x equal to the total wage at the start of this problem. And I said that Henrik was earning 3/5 of that original wage. So to begin with, he was earning 3/5 of 100. 3/5 of 100, well, 100 divided by 5, that's 20, times 3 is 60. So originally Henrik was earning £60, then he got a £20 bonus. So 60 plus £20, that's £80. So how much does Henrik earn in the week before Christmas? It must be £80. As I said before, this is how I approach this problem myself. There's a different method on the mark scheme, which may seem more straightforward to you. Let me know which method you prefer in the comments, if you had a look at both. Question 15 says, complete this table of exact values, and we have the sine of 0, the sine of 30, sine of 45, sine 60, and sine 90. So the way to remember the exact values is for sine 60, well, one way is to remember this right angled triangle. So there's a particular right angled triangle with an angle of 30 and an angle of 60, and we know that the side lengths of this triangle are 1, 2 and root 3, and we know the sine of any angle is the opposite side divided by the hypotenuse, so the sine of 60 is root 3 divided by 2. So that helps you to remember the sine of 60 and also the sine of 30. The sine of 90 is always 1. Part 2, Part B says triangles ABC and PQR are shown below. By working out the exact area of each triangle, find out which one has the larger area. If we look at each of these triangles, we're given two side lengths and an angle in between it. And that indicates that you need to use the sine rule for the area of a triangle, because the sine rule says that the area is equal to a half AB sine C, where these are the two side lengths and this angle C is the angle between the two sides. So using this formula, we can find the area of triangle ABC. So the area of triangle ABC will be half times 6 times 8 times the sine of 30. So the half of 6 is 3, 3 times 8 is 24, and then the sine of 30 we can take from our table, which is a half. So that's saying a half of 24, that's going to be 12 centimeters squared. And then the area of triangle PQR will be equal to a half times 3 times 8 times sine of 45. So a half of 8 is 4, 4 times 3 is 12, and sine of 45 is root 2 on 2. And then we can divide 12 by 2, 12 divided by 2 is 6, and then we've got that root 2 there as well. So can we compare 6 root 2 to 12? Yes we can, because 12 is 6 times 2. 6 times 2 must be more than 6 times root 2, because root 2 is less than 2. So we can see here that so 12 is greater than 6 root 2, therefore triangle ABC has larger area. Question 16 says the functions f and g are defined as follows. F of x equals 3x minus 1, g of x equals x plus 3 on 2. Evaluate f, g of 5. What this notation is saying is, what is g of 5? Once we find out g of 5, we can plug that into f of x. So the first thing we need to work out is g of 5. So if we plug 5 in for x, we'll get 5 plus 3 on 2, which is 8 on 2, which is 4. So g of 5 equals 4. Then we can put in 4 for x in f of x. So f of 4 will be 3 times 4 minus 1, which is 12 minus 1, which is 11. So f of g of 5 is the same as f of 4, which is 11. Part B asks us to find the inverse of g of minus 2. It's easy to get confused here by the notation. That's all they're really testing here. The arithmetic is not difficult in this question. It's knowing what this notation means. So g to the minus 1 of anything is the inverse of g to the x. What this is saying is g to the x equals minus 2. So if we let g to the x equals minus 2, then minus 2 equals x plus 3 on 2. So I've just put in minus 2 for g of x in this equation. Then we need to go ahead and solve for x. So firstly multiply this side by 2, so minus 4 equals x plus 3. And then minus 3 from this side, so x is going to be minus 7. So the inverse of g to the minus 2 is minus 7. Question 17 says, David says the value of the square root of x is greater than the value of the fourth root of x for all positive values of x. Decide whether or not David is correct. Show working to justify your answer. Well, let's see. So he's saying the square root of x is greater than the fourth root of x. Now, one way to approach these types of proof questions or justification questions is by putting in some real values for x and seeing what you get out. Let's say x equaled 16. The square root of x would be 4. The fourth root of x would be 2. 2 times 2 times 2 times 2 is 16. So he'd be correct if x equals 16. What if x equaled 1? The square root of x would be 1. The fourth root of x would be 1 as well. But that already proves that he's wrong, because he said the square root of x is greater than the value of the fourth root of x for all positive values of x. But if x equals 1, they're equal. So David is incorrect. And because it's only worth 2 marks, that's all the working out I feel that I really need to show. Probably if I did x equal to a 16th, I would get the square root of x equals a quarter, and the fourth root of x equals a half. So clearly David is wrong. Question 18 gives us a diagram, and it says a circle has the equation x squared plus y squared equals 80. The center of the circle is the origin O. The point P on the circle has coordinates 2a and a, where a is a positive constant. The tangent to the circle at P crosses the x-axis at the point Q and crosses the y-axis at the point R. Work out the area of triangle OQR. Okay, the first time you look at this question, you might wonder, how on earth can you work out the area of this triangle given the information that you're given? Because you don't have the base length, you don't have the height. So how can you possibly work out the area? Well, that's what we need to work out. How can we get the length and the height of this triangle based on this information? Remember, the base will be the x-intercept at Q, and the height will be the y-intercept at R. So if we can somehow find an equation for this line here, this line RPQ, we'll be able to work out the x and y intercepts, and then we'll be able to work out the area. So how can we get to working out the equation of this line? Well, we're given a few clues. We're given the point P. We're not given the exact coordinates of P. We are told that the x coordinate is twice the y coordinate, so we're relating those 2 points. And we're also given the equation of this circle. The equation of this circle tells us the radius. Remember, the radius in an equation of a circle is the number on the right hand side squared. So the equation of a circle is basically x squared plus y squared equals the radius squared. So the radius here is the square root of 80. So if we look at the radius of this circle, that's going to be the same as OP. So we know the length of OP, which is the square root of 80. Okay, how does that help us? How can we relate the length of this radius to these coordinates? What we can do is to create a right angled triangle with these coordinates and the radius. So if we draw a straight line down from P to the x-axis, we've created a right angled triangle with a hypotenuse of the square root of 80. Now the height here is the y coordinate, which is a. So the height of this right angled triangle is a. The base length is the x coordinate, which is 2a. So now we have a right angled triangle. We know all of the side lengths. And using Pythagoras' theorem, we can relate those unknowns and then solve for a. So we know Pythagoras' theorem says a squared plus 2a squared equals the hypotenuse squared, so the square root of 80 squared. So therefore, a squared plus 4a squared must equal the square root of 80 squared, well that's just 80. So 5a squared equals 80. So then a squared must be 80 divided by 5. 5 goes into 80 16 times, so a squared equals 16, so therefore a equals 4. So now we know that a equals 4, therefore we know the points of P. P must be 2 lots of A, which is 8 and 4. So now we know the point P. And now that we know point P, we can find the gradient of this line OP. Why would I want to find the gradient of OP? Well, if I find the gradient of OP, that will allow me to find the gradient of RPQ, because we know that the tangent of a circle is 90 degrees or perpendicular to the radius, and we know that gradients that are perpendicular to each other are negative reciprocals of each other. There's a lot of steps to connect here, but this is really useful revision. Working on problems like this is really useful revision for exams. So what I'm trying to do is get the gradient of OP. This is going to be the rise over the run. Now the rise here is A, the run is 2A, or in other words the points of P. So the rise is 4 on 8, which is a half. Okay, so I have the gradient of OP, therefore the gradient of RPQ will be the negative reciprocal of a half, which is minus 2. Flip it and add a negative sign. Okay, so the equation, which is what I was trying to get to at the start, the equation of RPQ will be y equals minus 2x plus c. And then I can use the point P, using P, which is 8, 4. I can plug that into this equation and solve for P. So plugging in 4 for y, 4 will equal minus 2, 8 plus c, minus 2 times 8 plus c. So this is going to be 16, plus it to this side, c is going to equal 20. Alright, now I have an equation for RPQ. RPQ will be y equals minus 2x plus 20. Now I have this equation, I know straight away the y-intercept equals 0, 20. Remember, this number on the end is always the y-intercept. The x-intercept, I need to plug in 0 for y, so 0 equals minus 2x plus 20. So minus 2x equals minus 20, so x equals 10. The x-intercept there is 10, 0. Okay, so looking back at the diagram, Q is 10, 0, R is 0, 20. That means the base of this triangle is 10, the height is 20, so then the area is equal to 20 times 10 divided by 2, which is 100. We finally got to the answer there. This is definitely a 5-mark question. Let's just go over the steps we took there to get to the answer. The first thing we had to do was find the radius of the circle, which is the square root of 80. And then we solved for A using Pythagoras' theorem and relating A to the radius. And we used Pythagoras' theorem, we found that A equals 4. So then we had the point P, which was 8, 4. That allowed us to find the gradient of the radius, which allowed us to find the gradient of RPQ. And once we have the gradient of a line and a point on that line, we can find the equation of the line. So we found the equation of the line RPQ, which is y equals minus 2x plus 20. Once we have an equation of a line, we can find the x-intercept and the y-intercept. And once we had those x and y-intercepts, we can find the area of that triangle OQR. Question 19 gives us a diagram, and it says quadrilateral OABC is shown above. OA equals 4P. OB equals 3P plus 3Q. I like to label my diagrams while I'm reading the question. and OC equals 6Q. X is the midpoint of OA. So X is the midpoint of OA. That tells me that OX is 2P and XA is 2P as well. Okay. Y is the point on OC such that YC is 2OY. Okay, so this is 2 and this is 1. Well, if this whole thing is 6Q, that tells me that, well, if I'm dividing that into 3 parts, this must be 4 lots of Q, this must be 2 lots of Q. And part A says express x, y in terms of P and Q. So this line here, x, y, I need to get from x to y using the vectors they've given me. Okay, well I know OY is 2Q. I know that OX is 2P. Okay, so if I start at x and I go 2Q, if I use the vector 2Q to go this way, then I can use the vector 2P, the negative of 2P, to get back to y. So this is going to be 2Q, this will be negative 2P, and that will get me to y. So to get from x to y, I need to add 2Q and then minus 2P. So xy will equal 2Q minus 2P. Okay, that's all right. Part B says show that BC is parallel to XY. So BC is here and XY is here. Okay, so we know that XY equals 2Q minus 2P. The way we can show two vectors are parallel is to show that they're a multiple of each other. So if we can get BC in terms of Q and P, maybe they'll be a multiple of each other and then we can show they're parallel. So how can we express BC in terms of vectors P and Q? Okay, so if I start at B and I go 6Q this way, remember 6Q is this vector here, and then if I go 3P plus 3Q this way, I'll end up at C. So I've just drawn two lines which are parallel to these ones. So this is 6Q and this is actually negative OB. So this is negative 3P plus 3Q this way to get to C. So BC must be 6Q minus 3P plus 3Q. Okay, so BC equals 6Q minus 3P plus 3Q, which is equal to 6Q minus 3P minus 3Q. Remember that negative has to be expanded to both terms there. And then simplify this, so 6Q minus 3Q, that's 3Q minus 3P. Okay, so now let's just factorize xy for a second. So xy is going to be 2 bracket q minus p, and bc can be factorized as well. This is going to be 3 bracket q minus p. So you can see that bc is some multiple of xy. So we can say that bc, so we can call that multiple k xy. So because BC is a multiple of xy, therefore BC must be parallel to xy. And that's all you really need to write for part B there. Question 20 is the last question of this paper, and the first part of this question says express x squared plus 4x minus 3 in the form x plus p squared plus q. This process is called completing the square. If you haven't seen this before, there's lots of good videos on YouTube about how to do this. It's easier if there's no coefficient of the x squared. So let me show you how you can approach these types of questions. The first step I like to do is to draw two brackets as though you're going to factorize this into two brackets. And then put your x's in, And then what goes in the end of this bracket is half of the coefficient of x. So the coefficient of x here is plus 4, so half of that is plus 2. And we get x plus 2 bracket x plus 2. Then expand that out. So use FOIL to expand these double brackets and you get x squared plus 4x plus 4. Then what you need to do is to look at this expression, x squared plus 4x plus 4, and ask yourself, what's the difference between this expression and x squared plus 4x minus 3? Well, if we subtract something from this expression, we'll end up with this expression. So x squared plus 4x plus 4 minus something will equal minus 3. So plus 4 minus 7 will be minus 3. So x squared plus 4x plus 4 minus 7 will equal x squared plus 4x minus 3. Now we know that x squared plus 4x plus 4 is x plus 2 times x plus 2, which can be written as x plus 2 squared minus 7. So we can write x squared plus 4x minus 3 as x plus 2 all squared minus 7. And that's your answer to this problem. What this allows us to do is to solve equations which we can't factorize. If you try to factorize this, you won't be able to. However, because we've completed the square and we've put it in this form, we can solve it pretty easily. So using this equation, we can say that x plus 2 squared minus 7 equals 0. So therefore x plus 2 all squared equals 7. So then x plus 2 equals plus or minus the square root of 7. It's very important that you do the plus or minus of the square root of 7 there. Let me just explain why that's the case. So if you have, let's say x squared equals 16, x could be 4 squared. It can also be minus 4 squared, because minus 4 times minus 4, that's still plus 16. Two negatives make a positive. So when you're taking the square root and there's an unknown on the left hand side, you need to make it plus or minus the square root of 7 here. Therefore x equals minus 2 plus or minus the square root of 7. That's what completing the square allows us to do sometimes. If there is a quadratic equation that we can't factorize into two brackets, we can put it into this form and then we can solve it just as easily as if we factorize the equation. Part B says the solutions of the equation y squared plus a plus b equals 0 are y equals 1 plus the square root of 2 and y equals 1 minus the square root of 2. Find the values of the integers a and b. Well, the clue to the answer to this question is that this whole question is around completing the square. So how can we use that idea to solve this question? Well, let's work backwards from these solutions. If the solutions are 1 plus root 2 and 1 minus root 2, then y minus 1 must equal root 2. And then if we square both sides, y minus 1 squared must equal 2. So then y minus 1 squared minus 2 must equal 0. So I've worked backwards to this form, and this looks very similar to this. So this equation is in the form x plus p squared plus q. So we can expand this out and then we'll end up with a quadratic equation in the form y squared plus ay plus b. Let's go ahead and expand this out and simplify to end up with some quadratic equations. So using FOIL, y minus 1 minus 2 equals 0. Using FOIL, I can expand these out. So that's going to be y squared minus 2y plus 1 minus 2 equals 0. So then y squared minus 2y plus 1 minus 2, that's minus 1, equals 0. So then we need to find a and b. A was the coefficient of y, which is minus 2, and b was the number at the end, which is minus 1. So that's all of the questions in this paper. Let me know how you went. Which questions did you find difficult? Leave a like if you appreciated this video. Consider subscribing if you want to see more content. Try not to stress too much. I know exams are a really stressful time. Try to take it easy. Try to find some relaxation time. Other than that, I'll see you in the next video. Bye for now.